video for Emi601, select a complex hypothesis, prediction, or conclusion supported by a data presentation or model. In front of you right now, you should have the skill sheet for Emi601 so that you can follow along as you watch the video with everybody else who's actually here in the lab for today. We're going to get started off by reading through the background information together to make sure we all understand what skill we're actually trying to complete here. Can I have a volunteer to read through the background information for the skill? Thank you, ma'am.
Emi601 skill is a comprehensive skill on the science. This skill asks you to complete a hypothesis, prediction, or conclusion that is started as a question. These questions comprehend and unfold it. This means that you need to pick and parse the process of the survey.
Excellent. All right, so what you'll actually see here is there's a sentence, and it's physically cut in half. The first half of the sentence is actually in the question itself. In the second half of the sentence, you have to choose. So essentially, you're choosing the second half of the sentence that best answers the question. All right, now as an example of that, we have this one below. So the question is, if you had 4 nickels and 3 dimes before giving away 25 cents, you would now have, that's the first half of the sentence. You then have to choose the second half of the sentence that best completes that sentence to make it true. So if we examine this, if you had 4 nickels and 3 dimes before giving away 25 cents, you would now have. Another key thing to think about with these is that there's oftentimes they're long sections of words that really just mean one number. So whenever possible, try to write down the number that that phrase is referring to. So if we take a look at this first one as an example, if you had 4 nickels and 3 dimes before giving away 25 cents, let's break that down and actually just write it out as numbers. All right, 4 nickels and 3 dimes is how much money? 50 cents. All right, 4 nickels and 3 dimes is 50 cents. Before giving away 25 cents. So then you gave away 25 cents. How much money do you have after you gave away 25 cents? Half of what it was, which is what now? 25 cents. So you give away 25 cents and you still have 25 cents. All right, so this whole first half of the sentence is saying we have 25 cents, which is a very complicated way of saying you have 25 cents. So now it's saying you would now have, and you have to make the statement true. Double the amount of money you had before you gave some away, 3 times the amount of money you had before you gave some away, half as much money as you had before you gave some away, or 1/3 as much money you had before you gave some away. The way that a pattern you'll recognize here is that the beginning of each of these choices are different. So double the amounts, 3 times the amounts, half the amounts, or 1/3 of the amounts are as much. But you'll notice the second half of these are all exactly the same thing. So if you could just figure out what the second half is, this question becomes really easy. So how much money did you have before you gave some away? What was our original amount of money before you gave some away? 50 cents. So each of these endings is actually referring to just 50 cents. So now all you need to think about then is our current amount of money, 25 cents. Is that double 50 cents, 3 times 50 cents, half as much as 50 cents, or 1/3 as much as 50 cents? Yeah, it's half as much. And that's it. All right, you'll often see these style questions as the last or second to last question on every passage, these kind of conclusion questions. All right, so you can expect to see these in the ends of passage questions. All right, let's take a look at the passage that we're going to examine for today. As we read through the passage, a common strategy we use in Superlabs is that we circle words that we don't recognize or we don't know. That way we can eliminate the vocabulary problem from completing the skill sheet. All right, so do we have a volunteer to read? So as our reader reads, what you should have in your hand right now is an implement of writing. As the reader reads and you follow along, you should circle, underline, highlight, however you would like, words that jump out at you that are confusing or tricky so we can identify them later. All right, our reader reads.
According to a simplified model of the hydrogen atom, an electron orbits a proton located at the center of an atom. The electron can exist only in certain orbits, each with a specific radius. When the electron jumps from one orbit to another orbit, a smaller radius of atom emits a packet of energy known as photon. The electron jump shown in figure 1, which involves the first 6 orbits, results in the 3 emissions of types of photons: ultraviolet, visible, and infrared. The energies of wavelengths of photons emitted due to these jumps are shown in table 1.
Oh, right. This is the shortest, most complicated passage that you can see. All right, it's only 8 lines long, but it can get really complicated really quick if you get lost in the vocab. So let's go through this and start to identify some of the vocab words that might trip us up as we are reading this. Did anyone circle or highlight any of the words that we want to go through together?
I circle ultraviolet
Ultraviolet,
and infrared,
infrared,
photon,
photon. Any other ones?
emit,
Emits. What do you like to emits? Good.
photon,
Photon. Good. That's it. Going once. Going twice. All right. The words that we have then are proton, emits, photon, ultraviolet, and infrared. So now there's 3 different ways that you can identify vocabulary words in a science passage. All right. The first way is they'll often be defined for you in the passage. So it'll say something like, a plant can undergo photosynthesis, the process of using light to make energy. And what that is doing is essentially giving you the definition of photosynthesis in the passage. That's one way. The second way is to use context clues or background information that you already know in order to get that word. The third way is to look it up. On the actual ACT, the third way, not an option. All right, so we need to try to use some background knowledge or context clues in order to figure out what these words are. All right, proton. Does anyone tell us where a proton is? Where have you heard the word proton before? Inside what?
Science.
Oh, in science.
Right.
All right, what is it inside of?
Is it inside of the cell?
It's inside of an atom. What kind of charge does a proton have? Does anyone remember? Positive, yeah. So it's on the center of an atom. If we were to take a look at a model of an atom, in the very center, we'd have protons sitting there. All right, next to protons would be, what else shares the nucleus of an atom? Neutrons. And then floating around the outside like crazy things are what? Electrons. Good. So little electrons, and these electrons go woo, and they fly around. All right, we have an atom. All right, that's a very non-balanced atom. That's okay. All right, so the proton is the thing in the very center. That's what we're looking at here. All right. The electron can exist only in certain orbits within a specific radius. When the electron jumps from one orbit to another, the atom emits. Does anyone know what the term emits means, or has heard the term emits? Yeah, it essentially means lets out, so or shoots off, or gives off, any of those terms. So it's getting rid of this thing, letting it go. All right, so the atom is emitting a packet of energy known as a photon. All right, does anyone know what a photon is? You might not have studied this in physics in the first year. A photon is essentially a packet of light. All right, light is given off in like chunks of light. So one photon is one tiny little packet of light. So if you were to look up at the lights above you right now, there'd be thousands of photons shooting off of that and actually going into your eye. And that's what your eye picks up as the individual photon of light. So it's like a little packet of light gets shot up. All right, and the last words were ultraviolet and infrared. Ultraviolet and infrared are essentially different spectrums of light. So we can see the visible spectrum of light. All right, that's Roy G. Biv. Red, there's blues in there, there's violets in there, all those colors you can see. We can't see ultraviolet light, and we can't see infrared light unless you're a predator. All right, by predator I mean the alien, the predator that has the infrared vision. You can pick up the heat that comes off of you and track you through the woods and hunts you down. All right, they can see an infrared, so they can essentially track your heat sequence. But we can't see that because we're not predators. All right, so they're just different wavelengths of light. All right. So let's take a first look at these diagrams. The diagrams here are super tricky. So let's start to identify some of the variables that are indicated in the diagrams. Does anyone see, let's start looking at figure 1. What are some of the variables that figure 1 is showing us? Like, what is figure 1 showing us that we can compare? What's one thing? Excellent. All right, the orbit that the electron is in. We see the orbit's name on the side, and they're referring to these numbers. All right, 5, 4, 3, 2, 1. Which one is the lowest orbit? 1, good. All right, and which one's the highest orbit? 6. All right, so the further the number is, the further away they are from the center. So on our diagram over here, orbit 1 would be really close, whereas orbit 2 would be further away, and orbit 3 would be even further away. Okay? What else do we see on here? There's probably one or two other things that we want to make sure that we can identify from this. Excellent. So we see our 3 different types of photons. We see these are all the infrared jumps, these are the visible jumps, and these are the ultraviolet jumps. Good. And then what is the last thing that we can tell from this, the last variable label from this? The jumps. Yeah, you can see the jumps themselves. All right, you see the jump possibilities can go through here. You'll notice that the way they're written is that there's an arrow. The arrow indicates the direction of the jump. So in this case, this jump, infrared C right here, starts at orbit 6 and jumps down to orbit 3. The jump starts at 6, ends at 3. All right, and you can see all the different jump letters that represent a different jump. So like this one right here would be visible jump B. That starts at 6, and that jumps all the way down to orbit 2. All right, that's what we're looking at in this graph. The second one, the table, is much less tricky. It's actually much more straightforward in the information it gives you. All right, so we see again the types of photons are 3 types. We see the jump letter. So the jump letter then corresponds to the same jump letter we were looking at over there. It then tells you for each jump what was the energy released from that jump, and also what was the wavelength of light emitted from that jump. So that you could look over here at this graph, and let's look at this jump right here. This is ultraviolet, jump F. So then we could go over to this table and find ultraviolet, jump, oh that's E, sorry, not F. Ultraviolet, jump E, and we can see that that jump released 13.2 electron volts of energy, and the ultraviolet wavelength was 93.8 nanometers. Ding. We have our data. Now that we have our data, let's get to our question. All right, what I'd like you to do right now is, if you are watching the video, you should pause the video at this point and try to answer questions 1, 2, and 3. The answer to question 1 and the answer to question 2 are essentially what we were talking about before, where you're trying to identify turning a whole long phrase into a single number, so that in 3, you can then compare those 2 numbers together. So if you're watching at home, you should pause the video now and answer questions 1, 2, and 3, and press play when you are ready to look at the answer. At this point, if you're pressing play, you are ready to go through the answers to these questions. You've already answered questions 1, 2, and 3. So let's go through question 1. According to table 1, how much energy is released when an electron emits an ultraviolet photon from an A jump? Okay. How do we get this question, and what is it?
I looked at electron emits ultraviolet photon, so I went to ultraviolet, and since it's asking me from jump A, it's 10.2 eV from an energy photon.
Brilliant. Perfect. Nice. All right, what about question 2? According to table 1, how much energy is released when an electron emits an ultraviolet photon, should be photon, from a D jump? Who can do this one for us? What'd you get?
I looked at table 1 and what the type of photon, and I looked at the ultraviolet D jump, and I got 13.1 eV.
Perfect. 13.1 eV. Now remember with this last question, you've already done all the hard work. Now you just need to know 10.2 versus 13.1. All right, it says according to table 1, the amount of energy released when an electron emits an ultraviolet photon from an A jump is, and then we have the same situation as before, where we have the more than, less than, equal to, and half of. Those are the only difference between all of these answer choices. All right, so as we're looking at these answer choices, the first part that we're given, what number is that equal to?
10.2.
Perfect. We already found that out. When an electron emits an ultraviolet photon from an A jump, we already found that. So we know 10.2. And then the second half of all of our answer choices, what number is each of those?
B, which is 13.1.
Yeah, B, which is 13.1. So all we have to ask ourselves is 10.2 more than 13, less than 13.1, equal to 13.1, or half of 13.1?
Less than 60.
Less than B. Huzzah. All right. If you are watching at home, what you want to do now is do the same thing with 4, 5, and 6. This uses figure 1 instead of table 1. All right, so you should pause at this point so you can answer questions 4, 5, and 6, and press play when you are ready to check your answers. All right, if you are pressing play at this point, that means you've answered questions 4, 5, and 6, and you're ready to go through the answers. Let's get started off with question 4. According to figure 1, how many orbits does an infrared sea jump cross? How would we answer this question? What do you think?
So I looked at figure one and I learned how to infrared in the fact that 6. And then I drew down to where it ends at 3, so it comes down to the other.
Excellent. So if you look at jump C starts here and ends there, which means it crosses 1, 2, 3 orbits together. Nice. So what we write here is 3 orbits. Units. All right. Let's take a look at number 5. Number 5 says, according to figure 1, how many orbits does an ultraviolet sea jump cross? How would we get this question?
You look in at figure 1, and then you go to infrared, and then you look for C.
Oh.
Ultraviolet.
Ultraviolet, good.
And then you look for C, and then you count down, and you do 3.
Excellent. So C starts here, and it ends right here, which means it jumps 1, 2, 3. Now the tricky part to see here is that orbits 3, 4, 5, and 6 don't finish their whole orbit. They stop. Like they just don't draw the whole thing. But that doesn't really mean anything. What you have to remember is that 2 and 1, they form kind of the whole circle here. But they're just the same kind of orbits that the other ones have. They just have the whole circle drawn. So just be careful of that when you take the test. All right, so this answer was also C. So then, when we get to this question, according to figure 1, the number of orbits an infrared sea jumps crosses is, so the first thing we need to do is turn this first phrase into a number. All right, if we're going to turn this first phrase into a number, how many orbits would this be?
3.
3. And then, if we look at our other ones, we see that, again, it's only the very first part of the question that's different. Greater than, less than, equivalent to, and twice that of. The second part of each of these questions is, you can just figure it out once and you got all of them. So what is the number of orbits an ultraviolet sea jumps crosses? What is that?
Equivalent.
Well, yeah, it's 3 again, which means that 3 and 3 are equivalent. Let's see. Fantastic. All right, since 3 is equal to 3, they are equivalent to one another. All right, what you want to do now is answer questions 7, 8, and 9 on your own. So questions 7, 8, and 9 on your own. Press play when you are ready to start going through 7, 8, and 9 together. All right, if you are pressing play now, you are ready to go through the answers for 7, 8, and 9. All right, 7. Based on table 1, the wavelength of visible photons emitted when an electron makes an A jump is, you got a whole bunch of options there. How would we tackle a question like number 7?
I looked at wavelength visible photon, and then it said that it was 256.
And which jump are you looking at?
A.
A. So we're looking for, so the first part of our question, the number we're trying to find is the wavelength of visible photons of an A jump. So you look where?
Visible A, wavelength. which is 656. And then I saw that says longer, shorter, equal, and brighter, and still the same.
Okay.
And I eliminated A, longer, longer.
Well, what number are you comparing it to? What is so like all of your questions are this? All of your answer choices are the same.
I'm comparing it to
Infrared, good.
infrared. A.
Good. So we're looking at the wavelength of infrared A. So infrared A wavelength is which number?
1,880.
Nice. So is 656 longer than that, shorter than that, equal to that, or brighter than that?
Shorter.
Shorter than that. Fantastic. All right, let's take a look at question number 8 using the same table. According to table 1, the amount of energy released when an electron emits an ultraviolet proton from any jump level is...
I noticed that we're looking for energy release in consideration. That we're looking for ultraviolet from any jump level.
Good, so we're looking somewhere in here. And we're looking for ultraviolet. Okay.
And then I noticed what we're trying to connect to, which is visible photon.
Excellent. So we're trying to compare these to the visible, not these. Trying to compare energies of ultraviolet to energies of visible. So now again, you could do it just like before, but you could write your numbers in. Except for this time, you kind of have a range. So if you look, the energy released from an ultraviolet has to be somewhere between what? What's the lowest energy from an ultraviolet? 10.2. And what's the highest it could be? Yeah. So we're looking at a number somewhere between 10.2 and 13.2. And then again, we're comparing it more than, less than, is equal to, half of. What are all these end ones equal to? What is the possible range of visible energies? 1.89 is the lowest. So what's the highest? 3.02. So is 10.2 to 13.2 always going to be more than, less than, equal to, or half of 1.89 to 3.02? Yeah, it's always going to be more. Nice. All right, as you can see, these problems can get a little more complicated. Now, instead of looking at individual numbers, now we're looking at ranges, comparing ranges. All right, they can even get a little more troublesome if you start to get a little bit if it starts to become a little tricky to find the number you're looking for. So let's go through number 9. How would you answer number 9?
So I looked at your one and I started at infrared and I know that it's 2,000.
All right, so the lowest orbit that an infrared proton can jump to, so we started at infrared, and you'll see all the infrared jumps stop here. So the lowest it can get is 3.
And it says, and then have a visible photon. So I looked at that and then it goes on to 2.
Excellent. The lowest visibles can go as 2. So is 3 higher than, lower than, the same as, or warmer than 2?
Higher than.
Yeah, higher. Okay, now these kind of questions are the most common way that you'll see Emi601. However, there are a few other ways you can see it. So you'll notice questions 10, 11, and 12 look slightly different than the way we've been practicing already. Please still do them in the same fashion. Try to figure out what numbers you're actually comparing there and write it in right in the question solution. All right, you want to work now on questions 10, 11, and 12. And these are the last ones. Press play when you are ready. Just check the answers. All right, if you're pressing play right now, that means you are ready to go through questions 10, 11, and 12. So question 10, according to figure 1, the only type of photon that can be emitted by an electron moving from orbit 4 to orbit 1 is the... Now again, this is still filling in the second half of the sentence to make it true. Well, in this case, the second half of the sentence is only one word. But still, you're filling in the sentence to make this true. So first off, we need to make sure we're looking at figure 1, which we have here. The only type of photon, so we have 3 types of photons, infrared, visible, ultraviolet, that can be emitted by an electron jumping from 4 to 1. So we need to look at 4 to 1. What is the only type of jump that goes from orbit 4 to orbit 1? So first, let's highlight the orbit. We see see this infrared one jumps from 4, but it stops at 3. So that's not good. This visible one starts at 4, but it ends at 2. That's not good. This ultraviolet one starts at 4, and it ends at 1, which is the one we're looking for. So in this case, ultraviolet, sorry. If we take a look at 39 and 36 together, again, it's the same style question. You just got to fill in what happens at the end of the poem. According to figure 1, if the electron in a hydrogen atom jumps from orbit 6 to orbit 3, and then jumps from 3 to 1, what will we emit? Now, if you look at this question and you're totally confused about what it's asking, the number one thing I would recommend doing is looking through its possible answer choice. Right, look at what they're giving you for choices. Notice a pattern in all the answers. All of the answers is either infrared, ultraviolet photon, infrared photon, infrared photon, ultraviolet photon, ultraviolet photon, infrared photon. All of these are photons. So we're trying to find the type of photon that makes this true. So, which type of photon would you get if you jump from orbit 6 to orbit 3, so from 6 to 3, and then jump from 3 to 1, from 3 to 1. So if we look from 6 to 3, the only one that has a jump that goes from 6 to 3 is infrared. Infrared jumps C right here. All right? It can't be visible D because visible D jumps all the way to 2. That's not the one we want. Same thing with ultraviolet. Ultraviolet can't be this one because this one will go all the way down to 1. We don't want that. We just want it to go from 6 to 3. So the first one here is going to be infrared. Now what about the second part, 3 to 1? Well, where does it jump from 3 to 1? The only one that jumps from 3 to 1, we see that infrared doesn't even have a jump from 3. Visible has a jump that starts at 3, but it ends at 2. So that's not the one. Ultraviolet has a jump that starts at 3 and goes all the way down to 1. So the second part is ultraviolet. So what would happen? They would release an infrared first, and then an ultraviolet. Last but not least, according to figure 1, a hydrogen atom can emit any one of the 3 types of photons when an electron jumps from all of the following orbits except. Again, sounds like a tricky question, but it's really not. We're looking at figure 1. All right, we'll switch to green for this one, just to be clear. So we're looking at figure 1. A hydrogen atom can emit any of the 3 types of photons. What are our 3 types of photons? Either infrared, visible, or ultraviolet. So it can release anything. It has the ability to recycle. When the electron jumps from all of the orbits, and the key part here is except. So what we're looking at here is which orbit, if the jump started there, would you not be able to release all 3 types of photons? So if we start with 6, is it possible if you start at 6 to release all 3 types? Well, look right here, it can release all 3 types. So 6 is not our answer, because 6 can release all 3. What about 5? Well, we have a jump that starts here, jump that starts here, jump that starts here. So 5 is not our answer. 4, we have a jump that starts here, jump that starts here, jump that starts here. 4 is not our answer. 4, 5, and 6 can release any of the types. We're looking for the one that can't. In this case, if we look at 3, you'll notice that infrared does not have a jump that starts at 3. Which means if you jump from 3, your jump starts at 3, you cannot release an infrared photon. So that's why orbit 3 is our answer. You've successfully taken all of these quiz questions. You are ready to go and take the quiz. Good luck.